Hello guys, welcome to Deep Codes, and in today's video we will discuss the question that was asked in the coding round of Adobe. So this was for the profile of MTS, so mostly Adobe hire freshers for this profile, member of technical staff, and this is an on-campus opportunity. So usually what I have seen that the on-campus opportunities are easier to crack, the coding rounds are easier as compared to off-campus opportunities, but I have found this post very well designed and with the most number of upvotes. So we will discuss the question from this post, right? And this was posted in May 2022, so this is not that old, right? So this guy has given us very well idea of what type of rounds are there, like technical round 1, round 2, as well as managerial round, and the lead code question link as well. And in today's video we will discuss the OA part, right? The two questions that were asked in the OA. Okay, so without much delay, let's start with our discussion. So the first question that was asked in OA says that get the minimum angle between hours and minute hand. So guys, this is not that difficult question. It only includes some of the basic calculation that you have to make. And yeah, I have found this GFG article on this that does the same thing, calculate the angle between hour hand and minute hand. So there is no complex logic here. There is simple calculation based on hour and current minute that you have to go through, right? So guys, go through this article. Now the second question is of the medium level, and the question says that check if the array has this type of triplet, that is I is less than j. So let's say you are given an array of size n, and you need to find I, j and k such that I is less than equal to j and that is less than k, and nums of I multiplied by nums of j equal to nums of k. So you need to find this, whether this is present in an array or not. So let's make the equation bit complex. Instead of check, consider count. You need to count number of triplets that are present in the array such that I is less than j and that is less than k, less than equal to j and less than k, and nums of I into nums of j equal to nums of k. So guys, the question is very much simple here. The description is simple and easy to understand. Now let's discuss on this. So for an example, if you are given an array like this, so we can take this triplet. See, let me also write the index. So 4 can be considered 2 into 2, and also note one thing, that I can be less than equal to j. So both we can take two numbers, right? Two same numbers also, because j can also be equal to I. So this is I, this is j, and this is k. So 2 into 2 is 4. So yeah, this is a valid triplet. Now 3 into 4 is 12, that is also a valid triplet, and 2 into 3 is 6, so this is a valid triplet. So total 3 valid triplets are there that satisfy the condition that nums of I multiplied by nums of j equals to nums of k, right? This satisfies the condition. So there are 3 such triplets. Okay, if you consider this test case, so you will find there are 4 such triplets. Well, see, this is k, this is I, and this is j. Right, 2 into 2 is 4, then 2 into 4 is 8, 4 into 4 is 16, and 2 into 8 is also 16. So yeah, there are 4 such triplets, and so we return output as 4. So overall the question is very much easy to understand. Now since there are 3 variables I, j and k, what is the brute force approach you guys can do? See, you can easily code this solution by using 3 for loops, right? Because since there are 3 changing variables, you can use 3 for loops and derive the answer, right? So yeah, this is the brute force approach that we will discuss. Here I have taken the k starting from 1, because 0 index k has no meaning. The first element can because no I and j will be present for the 0th index number, right? Because I and j both must be less than k, so we must start k from 1. And after that I took 2 inner for loops for I and j traversal and check whether if v of I into v of j equals to v of k. If that is the condition, then make count plus plus. Okay, see, I started j from I because j can be equal to I, so start j from I. So this is a brute force approach with a time complexity of big O of n cube, right? You can see the 3 for loops going. So this is the time complexity here. Now let's think of how we can reduce the time complexity. So what you can guys do, you can do one thing is, for let's say any given array like this, 2, 4, 8, 16. So guys, let's consider 8. Now we know what all numbers that can divide it. So let's say 8 divided by 1 is 8, 8 divided by 2 is 4, 8 divided by 4 is 2. So these are the numbers like 2, 4 that can divide the 8. Okay, we know that. Now what we can do is, for each number of this array we can find what all numbers can divide this. So we will find divisor of that number, and then we will check whether the divisor as well as the answer on dividing both are present in array or not. Both the numbers, if they are present, then we can say there is a number such that 2 into 4 when multiplied it gives the result 8, and yeah, we increment the count. So for each number, so we will check from 2 up till square root of that number. We will check how many numbers can divide that number, and we will also check, let's say x can divide a number n, x such that n modulus x is 0, n modulus x is 0. That means x can divide a number n. Also n divided by x gives a result y, and our array contains both x and y. Thus we can say n is nothing but x into y, x multiplied by y, and x and y both are present. So this is a valid triplet. Got it? And we also have to maintain this condition that I less than equal to j must be less than k. So these two numbers, that is x and y, must have index less than k, less than the. So what we are doing, we won't add all the numbers initially. Instead we will keep adding the numbers as we are traversing for k, right? We won't add all the numbers, but we will keep adding the numbers as we are traversing. So guys, this way, by checking for all the numbers that can divide the current number, we can check whether the triplet is there. So what we did here is, we run a loop from 2 up to square root of that number, and then we check whether if the number is divisible by that j or not. If it is divisible, then we will check whether the count of that number j is present in our map or not. And on dividing v of I divided by j, the answer count is also there present in the another map or not. If all these three conditions satisfy, only after that we are incrementing the count. So guys, if you are now talking about the time complexity of this approach, this turns out to be big O of n into square root of m, where m is a maximum number. Okay, now let's say in a worst case, let's say m is 10 to the power 18. So square root of this m is nothing but 10 to the power 9, and this would turn out to be very large number that might give you TLE. So this might give you TLE. So we have to again think of one better approach to solve this question, right? Now guys, we want to reduce this time complexity, that is n into square root of m. So think of different way how we can solve this question. So you are given this array 9, 4, 8, 16. Can we solve this in big O of n square? Can we solve this instead of square root of m? Because if m is a very large number, then this time complexity or this solution will surely give you TLE. So is there any way can you solve in big O of n square? So for that, can we do one thing, that we will only check for I and j, right? We will multiply all the different values for I and j, right, that are present in the nums array. We won't calculate and find the factor starting from 2 up to square root of the number. We won't do that. Instead we will multiply the numbers, let's say 2 into 2, 2 into 4, 2 into 8, right? We will multiply the number, and we will check whether any of these is equal to the current k or not. Let's say k is 16, then we will check 2 into 2 is 4, is it equal to k? 2 into 4 is 8, is it equal to k? 8 into 2 is 16, is it equal to k? Yeah. Then we will also check 4 into 4, that's 16, 4 into 8, 32, so no. 8 into 8, 64, so no. So we will check for each k different combination of I and j. That thing we can do, right? We can do this. But guys, we won't do this calculation for all the numbers. We won't do this calculation for all the numbers. Instead, we will smartly do this calculation. Because let's say when we are checking for 16, then at that time we will calculate for keeping I as 8, that is 8 into 2, 8 into 4, and 8 into 8. Now when we are checking for 8, then we will check for 4 into 4, 4 into 2, and then when checking for 4, we will only check 2 into 2. So guys, if you see that all these different combinations of I and j we are checking, right? We are already checking, and we will smartly check how. See, Now let's go to the dry run. So here I have started the loop from I equals to n minus 2 because n minus 1 is the last element and that can never be I. So the starting from the last element that is possible for I, that is nothing but n minus 2 index. So this is the loop now. Now after that what I will do, I will mark u of v of I plus 1, that is the last element, or you can say this is nothing but n minus 1 element inside our map, and this is nothing but our current k. This is nothing but kth element. Okay, got it. Now for this kth element we will check for the combination of I and j. See, currently I is here, k is 16. So what different combination we will check? We will check this different combination, that is 8 into 2. Is it, if multiplying 8 into 2 the product is present in the map or not? We will check that if the product of v of I into v of j is present in the map or not. If it is present, then simply make count plus plus. Now if in the next iteration I will come here and k will come here, right? K will come here and I will come here. So for that 8 we will check this combination, like 4 into 4, 4 into 2, correct? And we will, now 4 into 4 is 16, and we know that 16 is present in the map, right? So increment the count, right? So this way we will handle the condition that I less than equal to j and that must be less than k. So this is very much important condition, that the kth element will always have index greater than the ith index, and right, so the index matching condition will always be satisfied, as well as the time complexity here is reduced to big O of n square, right? Because we perform this multiplication of I into j only once, right? We only perform that once by traversing the array from the end, from the right side end, right? So yeah, by performing this way we can reduce the time complexity to big O of n square. So yeah guys, in this video we saw that how we reduce the time complexity from big O of n cube to n into square root of m to n square by using the extra space. So here we are using the extra space of this unordered map, that is nothing but big O of n extra space. So yeah guys, that's all for this video. Now guys, if you see that there are technical interview questions also given here. So this is nothing but a jump game 2 and a validated binary search. This is the easy level question, and this is somewhat medium level question. You can easily solve with one for loop using the greedy approach. Okay, and yeah, these two are some new questions. So guys, if you want a video on this technical interview question number 1 and 2, then do let me know in the comments. And for the managerial round, this min stack is easy, but this word ladder is somewhat difficult question that you need to solve. So guys, if you want a video solution in any of this question that was asked in technical interview or managerial round, then do let me know in the comment section. I will surely make a video on those questions. So yeah guys, that's all for this video. If you guys have any doubts, then do let me know in the comment section. I will provide the code GitHub link in the description. So yeah, make sure you check that out. Like the video and subscribe to our channel. Thank you.